So this is the 97 question, the one that had the ball where it dropped. So I think of it as two different problems almost. Yeah, because the ball goes down and it goes down 4 feet. But then the ball comes back up, but it only comes up half of what, right? So that's 2 feet. So then when it goes down again another 2. Then it rebounds and it goes up 1. That's supposed to only be half of that. So then when it goes down, it goes down 1 again. So for each of these that it goes up, it goes down the same amount. So that's a half. So like I said, I think of it as two different ones. So you have the ones going down, which were like 4, 2, 1, 1/2. Then you have the ones coming up. So it comes up at 2, 1. So that's why it has the double on those, because there's like 2 2s, 2 1s, 2 halves. Yeah, so it doesn't want just total distance going down. It wants how much has it gone back up, down, up, down, up, down. So that's what it's asking, is how much has it gone up and down the whole time. And so these are both geometric with r equals 1/2, right? And since this ball, it'll stop, but we said that it will infinitely keep going. And so it's an infinite one, so that's that formula, A1, 1 minus r for each of them. Sorry. So that's 1 minus 1/2. And this one, A1 is 2 over 1 minus 1/2. So 4 divided by 1/2 equals 8. And 2 divided by 1/2 is 4. So it travels a total of 8 plus 4, which is 12. So this is binomial expansion. Binomial means there's 2, right? Like bicycle, 2 sickles, 2 wheels. So binomial means 2 terms. So let's just start with x plus y to the 0. What's anything to the 0? And x plus y to the 1 power. And I know we normally don't write the ones, but for today I'm just going to write the ones. What's x plus y squared? So x plus y squared is that, right? Which is x squared plus xy plus, as you said, y squared. So 1xy and 1xy makes how many xy's? So we have 1x squared plus 2xy plus 1y squared. Then we have x plus y to the 3rd, which is the same thing as what we had from above times another xy, right? And it gets really ugly fast. Like, to the 3rd is x cubed plus 2x squared y plus xy squared. That's just distributing the x. You've got to distribute the y. So that's going to be another x squared y and 2xy squared plus y cubed. So that would be x cubed plus 3x squared y plus 3xy squared plus y cubed. So I'm going kind of fast on this. Like, it's just all the distributive stuff. But are you seeing any kind of a pattern? I'm not going to multiply the x plus y to the fourth out. It would be this x plus y times the previous stuff. So there starts to be a lot of terms. But it goes out to be this. X to the fourth plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the fourth. Are you seeing any kind of a pattern? What about your exponents on your variables? So the x's go down. 4, 3, 2, 1, no x's. So what do you think the next one's going to be if we follow that pattern? X to the fifth, x to the fourth, 5x to the fourth, that's right. This one's a bit trickier, but what's the x going to be? X cubed. Now, the x's went down, but what do the y's do? 1, 2, 3, they go up. So that was a y to the 1, so this is going to be y to the 2. I should have left more room. So this one's going to have an x that goes, the power on the x goes down, the power on the y goes up. Power on the x goes down. Whoops. My computer's being slow. So the power on the x's has gone down. Power on the y's has gone up until there are no more x's. So there's no y's to begin with and no x's to end with. Now here's the trick on the numbers. What's 1 plus 4? 5. What's 4 plus 6? So that 10 goes there. What's 6 plus 4? So that goes there. 4 plus 1 again. And then there's a 1 at the end. And it followed that same pattern up here. 3 plus 3 made 6. 3 plus 1 made 4. 1 plus 3 made 4. Up above, 2 plus 1 made 3. 2 plus 1 made 3. It'll always follow that with binomial expansion. Okay? They actually call these numbers Pascal's triangle if I take just the coefficients. So it starts with a 1, then 1, 1, then 1, 2, 1, 1, 3, 3, 1. Now the row that we just did with the fourths. So 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So Pascal's triangle actually generates the coefficients for the row that you're after. So like x to the fourth or x to the fifth was this one. And the numbers that we used were from this fifth row. So if you think of these as the powers out here, this is the 0 power, first power, second power, third power, fourth power, fifth power. Okay? So these are actually the powers on your expression. Okay. So we have 2x minus 3y to the 7th power. We're going to expand. So 2x is the first one, and it goes to the 7th. And then your x's go, the power on them go down. So we're going to have 2x to the 6th. And then 2x to the 5th. What do you know about the y's as this is going on? So this y is going up. So negative 3y to the 1, negative 3y to the 2nd, negative 3y to the 3rd, 2x to the 3rd, negative 3y to the 4th. What do you notice about these powers if you add them together at any one spot? What's 6 plus 1 at the beginning? And 3 plus 4 is? And 3 plus 4 again. So on every one, they will add up to be the same as the power on that binomial part that we began with. Okay? So as these go down, so 2x to the 2nd, I didn't leave space in front of that. The y's go up. And I'm going to run out of room. So 2x to the 1 power, negative 3y to the 6th power. And then the last one is negative 3y to the 7th power. So that's just taking the x's and the y's. But remember, they have the coefficient, which is this red line. Those go in front of each term. So there's going to be a 1, a 7, a 21, a 35, another 35, a 21, a 7, and a 1. So those red numbers come off of Pascal's triangle, and it's that whole row. Remember, these were the powers, like this is the first power, second power, third power, fourth power, fifth power, sixth power, seventh power. I should have chosen a shorter power. So that's where we generated the red ones. The green ones, we just took each term. So I took each of these two terms. The x's went down, the y's went up. And then we put the leading coefficients in there. Now you're not done with this, though. You have to do what John started to do and take these numbers and put them to the powers and multiply them all together. So you can get extremely huge numbers. As these go on, your numbers just get really, really big. So what did you say 2 to the 7th was, John? So this first one is 128 x to the 7th. Yeah, so it's still x is going to be to the 7th. Because really what you have is 2x 7 times, right? So if you had all those x's added together, it'd still be 7. So good. The next one, you're going to have 7 times 2 to the 6th times a negative 3. So
the x number is 448.
Do you do like 7 times 2 first?
I go, if I were doing it in my calculator, I'd go 7 times 2 to the 6th times negative 3. I would just type it in the calculator just like that.
Oh.
So 7 times 2 to the 6th times...
Yeah, that's right.
So negative 1,000... What? 44 x to the 6th, y to the 1st. Now the next one is going to be 21 times 2 to the 5th times negative 3 squared.
We got minus 6,040.
And that should be a plus, right? Because a negative times a negative makes a
Oh, that's right.
positive.
Plus 6,000.
So x to the 5th, y to the 2nd. Now your next one, that's a 35, times 2 to the 4th times negative 3 cubed. What's the negative cubed going to be? Positive or negative? So if it's an even, it will be positive. If it's odd, it will be negative. So 35 times 2 to the 4th times negative 3 cubed.
Minus 15,000.
120? So that's x to the 4th, y cubed. So the next one has 35, a 2 to the 3rd.
That's the same number.
It's the same number?
Yeah, because the last one was 35.
But they are a little bit different because we have the 2 and the 3 have different powers on them.
Oh, yeah.
So 35, 22,680. Uh-huh. X cubed, y to the 4th. So what do you notice about these signs? It goes negative, positive, negative, positive. So really, if you remember that, you don't even need to worry about the negative. You just remember the signs alternate because of the negative being squared, cubed, fourth. The first one will always be positive, unless if your first term is positive, just like 2x, this binomial term, if the first one is positive, it'll start positive. So then it's going to be 35 2 squared times negative 3 to the 5th.
That one's minus 20,400.
X to the 2nd, y to the 5th. And then you have 7 times, oops, that should be a 35, that's a 21. 7 times 2 to the 1 times negative 3 to the 6th. And then the last one you have just negative 3 to the 7th. $87. So that's how you expand those. So it's not that it's overly challenging, it's that you have to keep track of everything. Okay? Now, on your final and on your assignment, you're going to be asked to find, so this is the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term. They're going to say find the fifth term. When you expand 2x minus 3y to the 7th. So that's going to be the question. So we already know what it is. 1, 2, 3, 4, 5. That's this one. 22,680 x cubed y to the 4th. And that'd be your answer. But we really don't want to have to go through all of this because they're going to give you something like this. They're really mean. And they're going to say find the 8th term of 2x squared minus 5y cubed to the 12th. That's going to be your question on your final. Something like that. Okay. So we need to figure out a shortcut way so we don't have to go through 12 different things, go down to Pascal's triangle and do all of that. So there is a shortcut way. First things first, you all have a calculator? So on your calculator, let's try a few things. This is the 7th row, right? So if I go to my calculator and I hit math and I go over to probability, come on, and I go down to where it says NCR and hit enter. I'm going to put a 7 in the first one because that's the row, that was the power. And if I go 0, it's going to give me 1. Right? Second, enter brings that up again. I don't have to do everything, and I can just go back and change that to a 1. And that gives me 7. What are these starting to look like? See if your idea follows through. What are these numbers? Yeah, those are the Pascals, the 1, 7, 21. So if we do this 2 more times, it should give me 35 and 35. So if I change that 2 to a 3, there's a 35. Do it again, change that 3 to a 4. There's another 35. The next one should be 21. So there it is. Okay, so this is generating Pascal's triangle numbers. So with that in mind, if I want to find this 7th term, now realize this is my first term, second term, third term, all the way out. Are you good with that? But the first one, when we're doing this NCR thing, R is always 1 less than the term number. So R is always 1 less than the term number. So if I want to find the 5th term, the R will be 4. This N is always the same as our exponent on the outside, as our power. So that N is always that power. So N is going to be 7. If we're after the 5th term, R will be 4. So to find this number, I would go 7C4. So that's the NCR, and that's going to generate that 35 right there. So if we look at our calculator, 7C4 was the 35. Okay, so that generates the 35 that we have right here on that number. Now look at the power on the Y, on the second one, on the second one. That's a 4, right? That's always going to be the same as that number right there. So the y term, so negative 3y is going to be to the 4th. So it's always the same as this r value. And what do these two powers have to add up to be? The power on the 2x and the power on the y? 7. So this has to be a 3. So then I can take this and put it in my calculator, 7c4, and it's going to give me 35. And then the 2 is going to be cubed. And then the negative 3 is going to be to the 4th. And that should give me 22,680. So you have to do 7c4 first and get to 35. And then you multiply that out. Does that give me 22,680? And then just realize the x, that was with the x and that was the y. So, and I'll write down the general one after this problem. So if I'm doing this next problem, the 8th term, what's the r value going to be? 7, which means negative 5y to the 3rd will have a what power on top of it? 7. And 2x squared is going to have a what power? So the 7 and this one have to add up to be 12. So this has to be a 5. So this is going to be 12c7, because it's the r is 1 less than the term. So the 8th term, 1 less is 7, times negative 5 to the 7th and positive 2 to the 5th. And it's going to be a huge number. 12c7 is a big number. That's 792. And then you still have to times that by negative 5 to the 7th and 2 to the 5th.
Wait, where did the powers inside of
That, we'll deal with those. Yeah, we'll work with those in a second. So that's only on the x and the y. So it's only the x that's squared and only the y that's cubed. $1 billion? 980 million, and then so you did this and you put a 12 at the beginning, right? And so that when you told me it was 792, that's right. Times, you guys got different answers, so that's why I'm just looking at it. Oh, okay. So 1980, how many zeros? Like that? So that's multiplying. Oh, good, yeah. So that's multiplying those all together. So these are your millions, and then this is the billion, right? Now, John, you asked about this part, right? The y cubed to the 7th. What's y cubed to the 7th? Power to a power u times. So that's going to be y to the 21st. X squared to the 5th becomes x to the 10th. So this is the 8th term of this thing expanded. And that's what it'll look like on your final, most likely. And they'll have multiple choice. And they'll have like x squared and y to the 7th. And they'll have a positive 1980. So they'll have things that are really close that if you don't pay attention to, you'll get it wrong. Or they'll have, instead of an x squared, they'll have, what was this one? 7, 5. So they'll have a 7 here and a 5 here instead of the 10 and 21 stuff. So make sure you do the y cubed and x squared stuff. You want to do another one of those for practice? See if you can do it. So 2x squared plus 3y to the 4th to the 11th power. Find the 6th term when you expand this thing. I told you I was going to write this down. So here it is. This is how the powers will always work out. So notice how the y has the same r. And then this is the 12, the n minus r. So that's 11 minus whatever the r is. And r is always 1 less than the term. So anyway, that's the general setup to find any term. So NCR, the n is 11. C5, the x term, so that's 2x squared, is going to be to the 11 minus 5 power, which is 6. The y part, which is 3y to the 4th, is going to be the same as the r, so that's 5. Okay. So now you do 11c5, you're going to get a number, multiply that by 2 to the 6th, multiply that by 3 to the 5th, and then you're going to have x to the 12th at the end because you multiply the power to a power, and y to the 20th. So what do you get when you do 11c5 times 2 to the 6th times 3 to the 5th? Are you still doing it? So that's the 6th term of this binomial factored out, like when you expand it out. So as long as you can remember it, it's not bad. It's being able to remember what you're supposed to do with it. So I'll keep today's short, like under 10 problems. Maybe less than that. We'll see. We'll call that good.